Yeah, it's up.
All right. Sorry. So I've not been using Zoom to share. So I'm used to using Teams, Microsoft Teams. So I thought I could just take it as a brief. All right, cool. Okay. Um, try and arrange my desktop here. So how's the day been, guys?
Fine, thank you.
It's been
Was
okay.
anybody caught up in that traffic of Third Mainland yesterday?
No, someone like me, I work from home. So
Oh my, lucky people. I was caught up in it 2.5 hours. All right. Okay. My name is Segun Adelowo. If you don't mind, I would like to hear each person's name. I'll have a little mental note about the people in the session at the moment. Anyone can go first. Yeah, yes.
Hi, Segun. My name is
Hi.
Victory.
Okay. Hi,
Yeah.
Victory. Next
yeah,
person.
hi. My name is Charles.
Hi, Charles. Next
Hi,
person.
good afternoon.
Hey,
Hello?
hi.
Yeah, my name is Collins.
Good. Next, please.
Good afternoon.
Good
My name
afternoon.
is Temitayo.
Let me tire. All right. Next. Is that all? I thought I saw 7 people. So I think I was counting myself. Okay, it's fine. Let me go. So my name is Segun Adelowo. I say I'm a data scientist and I work at Interswitch. Um, so could someone help me with the right pronunciation? This Stuten, how best do I pronounce the organization's name?
So that would be student.
Stuten, okay.
Yes.
So Stuten has given me this wonderful opportunity to share what I know in line with what the team here might have covered in your various sessions at Stoughton. I'm pretty much going to, how will I put it, elaborate more or validate or confirm what you already know to some extent and share my views about some other areas and some other areas in data science industry. Yeah, so more like validating that student is giving you value that you came there for, and also adding more to what you've gotten from student to move up your career path and blaze the trail. So I thank student once again for giving me this opportunity to share what I know with the team. So what I'll be focusing on today is the feature engineering, proudly powered by student. So before I dive deep into this, sorry. Yeah. So I'll briefly want to talk about my journey to and in the data science industry. Well, if in Nigeria and out of Nigeria, as far as I can share as time will permit, we do not have much time. Yeah. So I started out not as data scientist. I started as a software engineer with Interswitch. Am I audible enough?
Yes, can you?
All right, cool. So I started as a software engineer at Interswitch. Well, before Interswitch, I was another company as a software engineer, but my career pretty much spanned the longest in Interswitch so far. So I started as a software engineer, primarily worked on um, payment applications and collections applications used at the bank branches, used on the web, and used on the POS terminals and your various ATM machines. So largely developing ISO based applications, backend reporting, interfaces, jobs, and all that, the whole shebang, as they would say. Yeah. So I did that for a while. And at the point, I felt, I don't know if it's just me or it happens to others also. I felt like, I think it was after like 5 years that I had peaked in my software engineering part so far within Interswitch. So there are other opportunities out there, but I like the Interswitch environment because it was central to commerce in Nigeria. As regards e-payments, in any discussion, if Interswitch or NIBS hasn't been mentioned, then we were not yet there. The discussion hasn't matured yet back then, but fair enough, they are good. There are some other players in the industry now making it more exciting also. So at that stage, I was wondering, like, what else could I do? Should I go into ethical hacking because I had interest in that, or should I jump into um, data reporting, business? It was the catchword then was business intelligence. So should I jump to business intelligence because I like the dynamic environment of data? You can't really cast in stone. Data is very fluid and you can bend it anyhow you want. So I was delete that around that. But long story short, I got into business intelligence a little. So I joined the team in Interswitch to build one of our first business intelligence applications for First Bank then. It was challenging, but we'll pull through it and it was awesome. So then I developed more interest about data and what could be done with data. Yeah, what got me was the bit about on our payment network being able to trace a customer's footprint along all our services. Oh, this customer with this customer number, oh, on this date bought this, on this date uses ATM, on this date had a transaction issue, on this date got a reversal. So you can see a train of what the person has been doing for like 3 months, and you could paint a story out of it. I said, wow, this is interesting. So I joined, so an opportunity came up, I joined the analytics team and I delved right into um, troubleshooting, analytics in the troubleshooting space. So I was mandated to, or I was charged to lead a team that will be monitoring our transaction success rates, failure, successful transaction. And the focus was to deep dive into the failed transactions and examine the root cause, pretty much do some sort of root cause analysis to find out what caused it at that point in time and provide them recommendations that other teams could act upon and prevent it from reoccurring. So I did about a year in that, and another opening showed up where the business needed to grow into the lending space started picking up. Oh, there were people coming up with lending fintech started showing up in the market, and Interswitch was poised for that also. A team was formed, and I'm the adventurous type. So let's go at it. So in that team, it was quite a challenge for me because I was mandated with the task of handling every data need the project will require. So I went from server monitoring, provisioning, making sure the respective teams are involved. I did analysis, deep database creation, I did reporting, I built SQL jobs, I built ETL services using SSIs, then I interacted with SFTP servers, from country to country, pulling data across countries. So it was quite challenging for me, and there was a KPI set to it, so I was always sweating. So, but with that challenge, it helped me stretch myself. So I went beyond my comfort zone and thanks to Google and Stack Overflow, a lot of reading, and some trainings I went for, I was able to deliver on that. That's how I got my analytics bits strengthened. So yet again, another opportunity opened up. Oh, there is a predictive analytics team that is forming, and they're looking for people that could jump in. And yet again, I jumped in, knowing that it would be challenging. But I'd always had interest of doing some stuff around data science, machine learning proper. So when the space opened up, I volunteered, and it wasn't. Are we here?
Yes, I'm
Yes,
listening.
yes.
Oh, yeah.
So it wasn't. If I'm boring, you just let me know. Also, I'm just. So it wasn't a. It wasn't a smooth sail when the new team formed. The good thing for me was it was a small team. So the task I had then was to work on a credit default project, which the company needed to push out the product into the lending market also. So I got some trainings, went from Coursera to Data Camp to O'Reilly, read books here and there, read up people's GitHubs, attended webinars, seminars. I was just stopping up. So I needed to know because of my stay in the company, there have been placed as some sort of specialist. So when it comes to data, oh, this is a go-to guy. So that picture had been painted and I needed to deliver for the business. So I had to be broad at that stage. I'll be able to answer any business question that was required of me to answer. And I went on, did all that. And so good, the product launched. Some of you might be aware of it. It's called the lending service, which many other lending partners write off to provide them loans to the Nigerian market. So which is growing now, and there are some learning points from there that don't always think, it's not always about the tool. So we got some very snazzy fine tools then, but at the end of the day, we solved it using basic SQL and some conditions because that was what the market needed at that point. So everything is not really about writing models and doing some fancy deep learning projects. So one is to have a good product mindset and use the approach which we call which I believe so you may be aware of, the MVP approach, the minimum value proposition. So what does customer really need at this point in time? Don't bamboozle the customer with, oh, this is the buzzword, this is the hype. If you're not doing AI or ML, you're losing now. No, just answer the customer's problem at that point in time, and over time, introduce the cooler, more techy stuff to the customer as the customer is willing to jump and run with you. So that's a big learning point from that. It's not about it's not about the fancy ML tool. Solve the customer's problem. The customer doesn't care how you get it done. Give me value. So I end up all that journey, that was the experience I got. And right now, so I'm based on the various projects I've done, I'm currently working on building it because of my software engineering background. So I brought in that software experience into my data science learning process and into the data business that the company went into. So I'm pretty much setting up structures and systems like a typical software engineering shop. So right now I'm
Hello?
working. Hello?
Yeah, good afternoon.
Good afternoon.
Yeah, actually, you're not very audible enough. I'm really trying to struggle to hear you. I don't know
Wow.
if it's from my end or.
I think that's from your end. I can hear clearly from here. I don't know if any other person is experiencing the same thing.
Yeah, fine or not?
Your voice is more audible than my own self. Yeah.
Yes, is it
Okay.
pick up a little?
Hello, is this better?
Yeah, I can hear you clearly. I think it's fine now.
Yeah, I think it's much better
Okay,
now.
fine. So let me get to a touchdown. So right now I'm bringing in the software engineering methodologies into data science. Pretty much have a more structured environment to build ML projects. So I'm building systems to drive CI/CD, continuous integration, continuous development, continuous testing, using Kubernetes, using Jenkins, using Airflow, pretty much have a system to automate the data science process from data gathering to deployment. So that's what I'm working on right now. And it's also, again, it's been challenging because there's a lot of reading to do. If there's one thing that you should not take for granted, there's a lot of reading to do in the data science field. You need to go out your way to read. Yeah, and there's been, while it's still in the industry, my journey in the industry, it hasn't been rosy all the while. So there are areas in my earlier days, there were a point in time where I asked myself, pardon my line now, who sent me message? I was like, what is this? What is this? So, and I had KPIs to meet, I had deadlines, and yet because of the interest and the drive, I did not give up on that. I pushed and still pulled. Yes, I was late on one or two projects, fine, but I ended up delivering what was expected of me, and I got the learning experience I looking for. So with that history, so I'm still writing on that. I keep learning, keep pushing myself to do new things and recommend for the business to do. The hallmark of being a data scientist is when you know you are doing the right thing is for everything you've done, you build a dashboard, you did some analytics report, or you build more a predictive model to predict XYZ of something. If it gets to be used by the business to make business decisions, then you are delivering value. But if you be all you just build reports and fancy emails that the business doesn't get to use, then we are wasting time and resources. So your goal, my goal, our goal in data science field is to make sure whatever we build delivers value. And let's not go with fine techie tools out there. Let's use what works that will make the customer happy so that we all get paid and continue to get paid. So that's a brief talk about my here and there in the industry. Did I make any sense? Were you able to get anything from all I said?
Yes, it was very insightful. Thank you very much.
Okay. All right. So don't take too much time. I'll move on to our next phase. Is my screen still visible?
Yeah, it is.
All right. So I hijacked this quote from Lisa. I got it online, which is quite interesting. As a data scientist, your mindset, your curiosity is satisfied through data. Much of data science is not the analysis itself, but discovering an interesting question and then going on a journey to answer it. See, data has a way to make things happen or make things better. With data, you can create predictive models that can improve almost anything and everything. Next, learn and apply the limitations of your tools. The tools in your toolbox are not useful if you don't know which one to use and when. Pretty much what I've been talking about earlier. Another one I like is the one by Pedro. Talking about this focus on feature engineering, said, at the end of the day, some machine learning projects succeed and some fail. What makes the difference? Easily the most important factor is the feature used or are the features used. That's, as a data scientist, your bread and butter is tied to how creative you can be within the at the feature engineering stage. So the challenge about feature engineering is not cast in stone. There's no formula to it. It's all experimentation. Your first set of 10, 50 features might look cool, but might not have enough predictive power for your model to go to production. So it's an iterative process which we need to keep hammering hard. So in a nutshell, so what we're trying to, so what is feature engineering? It's broad. I won't deny, I won't dissound. I'll tell you for a fact it's broad. So we'll pretty much just touch on a few areas of feature engineering to help validate and expand your non-understanding of feature engineering. From this small text are captured here also. This essentially is the essential stage in machine learning, in machine learning model development. And the part of addressing also, without warning, it can be tedious and it can take a lot of time. It has happened to me many times. I could be trying to engineer a picture and like, why is it not working? Why is it not working? But I did this, add more data. It's not always about adding more data. It's not always about adding more. I hear that get more data to make sense, but if you're getting more data and the features you created are not right, you still get the same result. So that part that I talked about takes a lot of time. It takes a lot of time because a lot of experimentation needs to go into it. So depending on data sets involved, a good understanding of the business or process that generated the data will be helpful in creating meaningful features. There's no point saying you want to. So here it's pretty much addressing the fact that you can't downplay domain knowledge. If you're in a lending organization as a data scientist, you need to understand how the lending business works. What is the business looking at? What is the credit analyst looking at as triggers that, so if a customer has XYZ attributes, or he pays his bills on time, his ATM withdrawals never exceed 20, never exceed maybe like 3 ATM withdrawals per month. Most of his transactions are done online, so you can easily track the person. Oh, his data with CRC is fair enough. Those are triggers that the credit analyst will look at to say, oh, this person is good for a loan of say 100K. So it's that entire business logic that you need to have, you need to build features around. You need to capture those business rules, not in if and else, but in features to give the model signals to pick and have a predictive power that's good to go to production. So you need to really focus on understanding the business itself. You can't downplay domain knowledge. Where it's lacking, ask a lot of questions. I'm sure we heard that a lot. Always ask the right questions. Ask why this. Ask how the process works. From your understanding of how the process works, how the business works, you get to be able to piece together the data that comes out of the business. At the end of the historical data that comes out that you need to build your models of or create analytical dashboards of. By the time you understand the process that goes into generate that data, you'll be able to build better dashboards, build better models, build better features to drive better models also, and create meaningful value to the employer or the owner of the project. Is that clear?
Yes, it is.
All right, cool. And so for what we're doing today, so these are the things we'll be looking at. Well, not directly, but these are some of the tools that we'll be making use of here and there as we go along this little journey of ours today, which I'm sure, are we all familiar with these tools?
Yes.
Yeah, we are.
St. Collins. All right. Okay, cool. Okay, so at the high level, this is what you'll be looking at. Under feature generation, split, apply, combine, simple feature generation from text, data cleaning, focusing on missing value imputation, and power transformations. Okay, power transformers. All right, cool. And the split, apply, combine can really be a little lengthy, but I'll just try talk about it a little, then we look at some code runs to have better understanding of it. Just add to what you know already. So here it says in data analysis stacks, a good way to understand the data is by breaking up data set into granular levels and carry out aggregations on it. This helps in seeing possible patterns where they exist. This is very useful in consumer segmentation and behavioral analysis. It also helps better understand the domain problem of someone new to the data set. I mentioned this earlier. At a high level, break up a big problem into small manageable pieces that are usually split. Operate on each piece independently, not applying a function or a method, some sort of method on it. Then put all the pieces back together So you can later use it in the next stage of your analysis project, combine. Then a graphical view of split, apply, combine. Your data frame to the left, column 1, column 2. When it goes in the split stage, this is what happens behind the scene. They get broken up by the index you use. The index is on the left, the yellow ones, and goes all the way into apply. Under apply, you use aggregators or transformers on your apply, sum, mean. Then at the end of the day, your output is in a combined state. So this combined gives you a new data structure that you then feed into the next stage of your project. Okay. 1 sec, please. Let me pull up my, I hope it doesn't time out on me, my collab. Am I making a little sense so far?
Yes, very well.
Okay. Where did my collab go? Okay. Is my collab visible?
Yes, it is.
Okay. All right, so yeah. Let me just see if, so I have two data sets in this short run through I want to do. One is transaction based, then one is from the classical Titanic project. So let me see if I have it running. Yeah. So this data set contains retail transaction data from an online store. Purchase is pretty much, bought this, bought that, this country, that country, an online retail store. And there, from what we can see here, there are about over 500,000 records here. But for what we want to do today, this 500,000 will be too much. So what I did was to use this parameter in the pandas data frame sample, pretty much to subset, get what we statistically call the sample population. So I just want a sample of this over 500,000 records to deal with. So that I'm trying to, so here what this also speaks to is that because you have 200 million rows of data or 10 million rows of data or a gigabyte, doesn't mean you should use everything for your analysis. At some point, because of the way, because of the sheer volume, it might not even fit in well. Some of your mapping or graphing tools will just punk out. So it's best, so statistically, it's advisable to take a sample portion, a subset, because it's a representation of a larger universal set, a larger population. So it helps with doing quick analysis, and based off of your analysis, you can infer from your result that, oh, if the sample population has XYZ attribute, that means the larger population will have these attributes present also. Instead of you loading the entire population into your notebook and just make it time out or punk out. Do we get?
Yes,
Yeah.
yes.
Yeah.
Yeah.
So sample lets you do that. So this sample, from description above, say return a random sample of items from an axis of the object. So what this does is give me 0.01, a fraction of 0.01 of the entire 500,000 records. Replace means do not repeat records twice. If you've done statistics, so there's with replacement or without replacement, I mean, do not, for every random record you pick from this 500,000, do not create a duplicate of any. Let each one be unique. So that's what I mean by replace false. I mean, let each one be unique. So I want to just get enough representation of the population as much as possible. If this was set to, if this was, you will say, okay, let's take, okay, I'll come back to that. So just give us a portion of this, which if we run, it's what we have below really. We run the next one, just to confirm. So 0.0001 is 542. You can do the comparison. So from over 500,000 to just 542. So if you adjust that also, if you say you want 0.1, if you do that, sorry, I'll do this. So this is 0.1 of the 500,000 records plot. So do we get what I'm saying so far?
Yes, yes.
All right, cool.
Yeah.
So I pretty much use, because most of the transactions, one of the data sets I work with at the office are large transactions. In a month, like one of the projects I work on also, a month's worth of transaction, it's about, now this is me being modest with the records I've seen, about 400 million records, 400 million rows in a database table, not the entire database now. Just a table is 400, excuse me, just a table is 400 million. Tell me, is it wise to pull 400 million into my Jupyter notes?
It will crash.
Yeah, so, but I still need to work on that data set. So what I end up doing is I just point I take a subset of that 400 million at random. Maybe I do like 10 million. I have that 10 million. I now take like a million of that 10 million. So just get a small set that can represent the population the best way possible. So I use this a lot. So let's return it back to what we had before for the sake of our graphs below. Okay, yeah. So we have this, that's the shape, then the content of our data. Invoice, I told you an online shopping service, invoice number, stock code, item description, quantity, invoice date, unit price, customer ID, country. Because of what we need to do down below, we need to create, I need to derive this feature now because of where I'll be needing it below. So unit price by quantity gives us sale. Sales was not originally in this data set. So it's pretty much some form of simple feature being generated to help address what we needed below. So if you run this now, for every row, it does the computation and we'll have, yeah. I have a new column at the end, sales, just computation, quantity by unit price. That's value. Then here, definitely this one has been, so at this point now, as a data scientist, I'll need to engage the business owner or the source of data set. Why do you have a quantity of -2? And you have a unit price to it. It could be 1, 2, 3, it could be any reason. My first intuition will be to say, oh, the item was returned, faulty item, or transaction error, or it could be anything. So it's good to have, and on getting this -2, meaning it was a loss to the company. So whatever it was, the company had to part with money, or the goods were lost in transit, and the company had to give the customer a refund. But it needs to reflect in the company's books that, oh, we sold these items, but we had to refund the customer. The items were lost in transit. The customer was very angry and did not want a replacement, or we give the customer a different item as a replacement. So it could be anything. So everything being captured either means something or not, but we need to confirm from the data source, from the data owner or the business owner, what that anomaly is before we move on. We good? Hello?
Yes,
Hello,
yes.
yeah, I can hear you.
Okay, so I need to keep pinging back and forth to make sure I've not lost you guys and the network hasn't failed me.
No, at all. Yeah, we're good.
Right, cool. Then we need to drop this columns. We'll not be needing it right now, well, for this segment. So we run this and do a, so what I want to do is to do a little plot of quantity sales by country and stock code just to see what data looks like. It's not fun just looking at rows of data. It's hard to pick out anything from it. So I just do that, just see, try to visualize what lies beneath. Why is it taking time like this? Okay. It's quite tiny, I know, so I'll just try to zoom a little. Yeah. So this is just as data analyst or science or data professional trying to understand, oh, what's that this data even? Oh, country, United Kingdom. So by country, for each country, maybe I'm trying to generate a report. Sales count by, yeah, sale value of sales by count for each country, something like that. So for each country, number of sales, quantity, and the color code. You see these various colors are the hue. It refers to stock code for each, because the stock codes are like identifiers of each item being bought. So pretty much some form of clustering, or all these greens are similar items. All these purple are similar items. Where you have more than one dot of gold, similar items, in various amounts for each country. So there's nothing too much here, but just to have a little insight into what the data behind looks like. We can leave this part then. So talking about split now. So ideally, in having a good grasp of any data set one is given, I mentioned earlier, we'll first need to break it apart into small pieces, then find out what we can find out, pretty much. So here in this step, we create groups from data frame, from transaction data frame. In grouping them, we'll use country to put them into various buckets. And that's what split helps us do here. Group by the column country. So the data frame we created, transactions, group by country. Then we do print type. I mean, let's see the internal. This data frame we have here that we've called data frame. What data type behind the scene to better understand split. So behind the scene, this object we created here, this group by country, is type group. Yeah. So in this type group, what finance has done is to take these data sets and internally truck it up into various groups by their various attributes. So let me just go down to, okay, yeah. So yeah, for the text I have here, so once you apply the group by function on the data frame, it creates a group by object. A group by object stores the data of the individuals groups in the form of key value pairs. We'll see that below now, as in dictionary. To know the group names, we can either use the attribute keys or use the attribute groups of the group by object. So if you do a simple for each on the group by object, we can see the content. So here is just listen out. So if you notice here, Australia, Belgium, well, I do not pronounce this, France, Germany, these are group names. So we said group by country. These are the countries, yeah? And it says it stores this value in key value pairs, as in a dictionary. So this is a key, and these are the corresponding values. So this all goes on behind the scene before you even apply any function or aggregation to your group by object. If you want to see the details, the data stored in here, even, let's use so this is a simple for loop. So for each key in this group by object, print the key and print the value. And that's what we have here. So it did Australia, stock, quantity, unit price, Belgium. So for each country, which is a group, it has grouped the corresponding data into each country set. So this is like, so a group by is like a collection of data frames within it. Group name, so like that all the way down. Let's just quickly move on. Where is, yeah. So that's pretty much what split does. So it breaks up your data set into whatever group you've assigned to it to use in splitting up your data frame. Apply is the next interesting one. So whereby I apply some function on the object, I apply, excuse me, the apply set can be performed in 3 ways: aggregation, transformation, and filtering. I will pretty much just touch on one here, so it don't take too much time. Aggregation. Sorry. Combine is, yeah. What is happening to my, okay. So if you look at this, we said here, transactions group by country and sum. So meaning for each country here, sum up every numerical value summable. That's why I have Australia, just 1.4, Belgium, 32, unit price, so summed up each one. Then pretty much the same thing, just sum up all numerical values by the country which is being grouped by. Then if you notice here where it says index as index true, meaning use country, more like this group by key. Use group by key, which is country, as our index. If you want to flatten this, which just as index false, and we'll have this. Let's still be sure our data frame is still fine. Yeah. Index is false. Sum every numerical value and flatten it. So country is flattened out. Planners now does, excuse me, does this thing, gives it its own index to be able to iterate through the table. That's largely what we have for aggregating on our group by object. Then another way we can use the aggregation is by grouping with some other additional functions, meaning we can introduce additional things to our group by function here. So we've group by country. Yes, use country as the index. Now aggregate based on the following, excuse me, sales, get the sum of sales. This is using NumPy. get sum of sales, get get the median of quantity and the mean of quantity and counts of transactions. That's what we have here. Australia, we have one transaction. The mean is definitely one. Median is one. Sum 1.5 is minus 1.5. So these are normally we have in our data set, which will be noted down and we contact the business owner to get more details. Belgium, 4 transactions, the mean, the median, the sum. So depending on what you want to do or the business problem you're trying to answer, you can play around with this, add more functionalities and see where it takes you. It's not cast in stone. There's no way of solving a data science project or analysis project. Just go at it with the tools you have and whatever I can creatively come up with. Moving on also, you can introduce a function to our aggregation also. In order to first create, in order to add aggregation, the scenario where you need this is, for that business, you're required to compute, the business wants to do some form of loyalty scoring system whereby they get reward customers that have certain loyalty points based on how often, on how well they've been buying goods from the online store. So a business function is defined based on an existing business process. It's just a random function I just cooked up to represent a business function. So business rule, country customer loyalty discount point. The discount is the mean of that group multiplied by this and subtract this value from it, return discount. And in applying it, let's run this. Yeah, it's still fine. So we say group by country, then for each sales column or for each sales data point in that particular country, apply this business rule and return the mean also. So what it does is for each group here, Australia passes in the values, it does the computation and returns it for that particular group. So in this way, you can embed functions, as many functions as you want, into your computation to return a fancy data set for a dashboard or something. Are we following?
Yes.
All right. So just a little info here. Oh, at a glance at the data, customers in Sweden will get the highest loyalty discount point based on the application of the business rule to the entire data set. This is 7.8. Whatever that means to the business, the business is happy, they take it to the board and the necessary decision is being taken and everybody is happy. So I just want to reiterate here that as data scientist, make sure your work is in the line, I'll up it now. It's in the line of sight, something like that, meaning whatever you do, let it tie directly into the business's day-to-day activities. Let your work be so valuable that it will be used by the business to make decisions on a day-to-day basis. Then you will know how well you are doing and how well you are not doing, and you will see the necessary room for improvement you need to make. Then, okay, group by the numeric columns. So before now, I've just been group by country. Let's just do a group by a numeric column, pretty much deriving a category from a numeric column. So we create a panels series from our sales condition. We're saying, let's store all sales greater than 100. Then based on the condition we set above, the series is a binary result. This series, a binary result is set for the rows. Let me say something here. So based on what we captured here, this is the result. Say greater than 100. So this is in a bitwise form. So because we did this, pandas returned the results as a pandas series object. That's why it's having false, false. So at the bottom, there's true somewhere there also. So it's type bool. So in next we say, okay, how do we make sense out of this? So create a dictionary to describe or label the binary result using a map function. Map binary value true to sales more than 100 and binary value false to sales lower than 100. This was just trying to create some form of visualization from numeric data and trying to make sense out of data itself. So here we say in this search object, for everywhere there is true, let's say the corresponding sales more than object, sales more than 100 label. For everywhere we have false, set sales less than 100 label. We run that and we use unique to see the count, the variation, just okay, how many items really are in there. By the time we do this, it returns, our array contains label this and label this for the series object we just worked on. Now, here, so we take this series object we have here and feed it into our group by on our transaction data frame. So this is easily understandable by the data frame because the index in this sales category is the same index in this transactions data frame. So on applying the group by, it matches, and based on this index, it maps the corresponding values and applies the mean on the grouping we've done. So we pretty much created some form of group by. So we reduce data from these lots, map this into true, false, and true, giving labels. Then now applied group by on this label that we have here and used the aggregation function of mean on the sales to give us some form of representation. It could be anything. This is just me trying to show something at a tangent that okay, we can also do this using our series, our pandas map function of our pandas series object. Not to take too much of your time. Next we go to combine. So what combine pretty much does in summary is it takes the result of your apply and transform and returns a data structure, be it a pandas series or a pandas data frame at the end of your aggregation or transformation so that it tallies to some extent to the initial data input you gave it. So it looks like this. So the whatever you have at the end is similar to what you had at the beginning after applying your numerous transformations. Okay. So let's quickly go through this. Yeah. So if we take this, one sec, please. Let's get this to 5. So we say, let's run this also. Yeah. Group by country, just a column. Sum, get the mean of the sales. Whatever returns, we have a series object. Pretty much because we're computing off one column. If we do this on 2, sales and quantity, we'll run the same thing. If we do get the results, what we'll get back is a data frame. This is just trying to show us what the internals look like. If you run just on one attribute, compute the mean of one attribute, by default, pandas returns a series object. If you run your data frame of two attributes, complete of two attributes, by default, pandas returns a data frame. So most instances when I work on stuff like this, I'll end up creating a new data frame to absorb this in and cast more like you just cast it into a data frame back. So you can use it down the line. If a series subject is not what you wanted, then you need to take this result and put it into a data frame to work with. I'm just trying to show one or two things about the internals. Then we're going to, generating feature from text. So in here, we'll be using the Titanic data set. And I believe we're familiar with it. I hope it's loaded. Are we here?
Yeah.
Yes.
Okay. I hope I'm not boring you guys. I'm not good at plenty presentations like this. Okay, yeah, so this is sample data we'll be looking at, the Titan data set. I got it off cargo. Let's confirm start. Yep, so this is what we have: a name, sex, age, SID means siblings, parent or not, tickets. Now, the focus is to generate a text, to generate a feature from a text. So now that we need some form of function. We're using the apply function to extract title from the name attribute and mother from a combination of age, gender, parent or not, which originally wasn't here. If you notice in the name data point here, there's a Mr. here, there's a Mrs. here, there's a Mrs. here, there's a Mr. here. You will need to apply some form of text manipulation and just get this out and put a separate column. All we're trying to do in feature engineering is bring out key features, key attributes, key patterns, let it be opened up in tabular form so that when a model, your supervised or supervised, any supervised or supervised learning algorithms choose over it, it's easy for the algorithm to pick out signals and be able to make a strong prediction based on data I've given it. So the main goal of feature engineering is to be able to structure the data in such a way that meaningful attributes are exposed for the model to pick and learn from. That's your lessons. So here, we'll focus on creating title and mother. So for title, we have this function. It's just a simple if else. For each record, after passing a name value, if this value exists inside the data point being passed in, return Mr. If this, if that, if this, if that. So you know, I had coding down a business rule, some form of business rule. That's okay. For this population on the Titanic, it's a mixed population. They are not all they categorize different people in society. So people that are Mr., Mrs., Master, Miss, and some other that are not documented properly. But this in itself, it's a good thing for the model. It will help it to know and identify the data points a lot better. So we run this function so that it's aware. Then we apply it. Say, using the apply function, Titanic, name, title, passing title, do a count of what we have at the end of the day, just to be sure. We run it and voila. So for Mr. 500 plus rows had Mr. in it, 182 had Miss, Mrs. So these items we're able to extract these things out. So we could just view, before we go to mother, could just do, I think I did that below, but before I get there, just a quick peek. Oops. So we have our new feature, title, Mr., Miss, Mrs., Mr. Next, let's do for mother also. So what condition are we looking at? The condition is, it's up to you to decide what works based on the business context you've been given. So here we say, we'll create a new feature called mother. If the person is female, has more than one child, has a child, more than one child, has one or more children, either is over 18, title is not Miss. So it could be anything. It depends on what you're being given to work with. Same way we create a function for that and say, oh, in this data frame supplied in, if sex equals to female and patch equals, and patch greater than 0, meaning I noted it here, patch, number of parents or children aboard the Titanic. So patch greater than 0, age greater than 18, title non-miss. Now we're able to use this because we derived it above. So you see the value. So one feature can lead you to reusing it in another segment down the line in your project. So title is not means, return mother, else return not mother. So this is not, it's not going to capture everything 100%, but it still gives some form of signal. So we apply to a mother, data from Titanic, apply. We do that and do a count. So mother 52, not mother 83. If we view everything again, yeah, title, Mr., mother, mother, no mother, no mother, no mother. So now this is a case of where it's not cast in stone. You need to go back and tweak your conditions to see if it fits or not, or why this doesn't fit. That's why I'm like digging deeper into whatever condition or feature created. It doesn't just work out of the books like that. No, it's not always 100%. So like here now it says Mrs. is not mother. Why is it not mother? The closest thing we can point at is, oh, okay, this is 0. Do you get what I'm trying to say?
Yeah.
Yeah. So that's a simple way of generating a feature from a given text. And also bear in mind that it's not always going to work 100%. You just need to keep tweaking till you get what works best. And not at the expense of the business, but still in line with what the business wants. Okay. So missing value, okay. Imputation, so running out now. So here, not, as you all know, data doesn't come perfect. Yeah, the cleaner the data, the better, but in most cases, it's not always so. Like at work now, the saying is true. When I first started out with data science, I hear a lot about, oh, data professionals spend like 80% of their time, over half of their time cleaning data. I didn't get the full grasp of that until it hit me on one of my first projects. The data was not clean. I spent like a week or two trying to make it usable. Nulls here, empty here. Oh, I had to figure out, okay, where can I get extra data to enrich what I have already? Oh, can I combine the data I have right now, the data set I have right now of customers? Let's have customers data, customer demography, name, gender, and all that. Can I combine with something else in the business domain, like a CLC report, or can I combine it with festivity? So there's no one way to go at cleaning your data. By the time you remove all the funny pictures out of your data, you try to use, you need to make it more rich by adding excuse me, extra stuff into it. So in the act of you replacing or imputing missing values, in itself, it's not enough. You need to say, I can take your data out of where it is and add other things to it. That's where you begin to shine as a data professional, being creative with whatever you're being given with. You could just go and say, oh, let me clean up the data set, remove the nulls, do input value, inputting missing values where needed, and you're done. Yeah, you've done the work, you've gone, but is that all that could be done? So those are things that show up when you're doing your work and when your code is being reviewed. Those are kind of things that show up. Your creativity shows up and helps in the business decide whether, oh, this person is good to get a promotion. This person is always thinking out of the box. This person is always going the extra mile to get value out of this data. So those are kind of things you need to be doing as a data professionals to stand out and not do the work as required, but go beyond what is required. I also just mentioned that there briefly. So in this data set here, age year is missing to some extent. Cabin is missing, almost gone, 77%. Age year is about 2% gone. Then embarked, a little missing. Others seem fine. Now what we can do here, summary of what's missing. So for the age imputation now, the question to us all is, how should we best impute the missing age of the passengers? Do we use the mean or the median? Would the mean be a realistic approach to apply to every passenger on the Titanic? What's your take? Can anyone share their thoughts around how best to apply missing value imputation for the age attribute? Anyone wants to give it a go? Hello? Collins, you want to try?
Hello.
Yep.
Yeah, please, can you repeat the question, please? I was lost, right? So.
Okay, so in addressing missing values have a way of disrupting or giving our models false data, leading us the wrong way. So they need to be treated. So in handling missing values, for example, age is 20% of our age here is missing. So how best should we impute values that represent something usable that the model can use? Do we do a mean of the age, or do we do a median of the entire age and use it to replace the missing 20%? What do you think is best?
Yeah, I think we can use the mean of the age here.
And you believe will be fine?
It will be fine in a way, sir, because in the aspect of the age now,
yeah,
some of them might actually be kids. You get me? So we have to also consider that fact, because like if we should look at the average age should be around that, let's say roughly around that 28 or 27 years.
Yeah.
Yeah. So probably we should look at if the person is actually a parent, or if the person is actually how will I put it, aged child.
Okay.
I don't know, maybe if you get what I'm trying to say, sir.
Yeah. So you pretty much addressed and spoken to what I did underneath also. So it's good to look at from the context, which is mentioned also. Oh, there might be kids on board. Oh, there might be elderly ones on board. Oh, how best do we do that? So, in essence, what we're saying is we shouldn't try use a blanket field saying or just take the mean of the entire data set and apply, or take the median of the data set and apply. It will be good to have more. It will be good to know and have more context around what's represented in the data so we can apply appropriately, which you've also rightly mentioned. Yeah, nice one. So which is what we have here. So I did a small, I got a small plot of, where did the second one go? So applying, so this is just plotting the age without applying any missing value imputation, just plot and that's what we have. Then this is using imputed mean, like what Colin said. Oh, yeah, apply the mean as what we have. And this is using, below is using the median. But it doesn't give us a smooth, so this spike here, it's not going to help our model. So we need to find a way to smoothen this out. So which means this is not the best approach to go. It's so far from this Gaussian representation here. It's so far from it. So we need to find a way to address this. So the context of, oh, what kind of passengers are these comes in, and we could try figure something out by using their title. So imputing values based on the passenger's title, the title we extracted earlier. Like Colin rightly said, oh, there could be kids there. Yes, there are kids there. So if you do this, group by title and get the mean of the age. So these are bringing our group by into here. So title, master, miss, Mr., Mrs., others. So this is where kids are falling. So if the mean age is 4.5, then this is a kid. So pretty much at that time, for the young ones, oh, Master Thomas, Master Collins, the likes, that's how the registration have been done. Then Miss 21, Mr. 31, Mrs. So this gives us a good view of how the underlying data set looks like. And if we had applied the median on mean across the entire data set, we'll pretty much be saying, oh, the children here are 21 or 32. Will have caused more problem to our data set than the good we want. So same thing, if you look at the median of it's not too far, similar. So, which I mentioned this earlier also, 4.5 and 3. So the way to go about is to impute by context. Like I said, if we had applied age across the entire data set, this is what we're saying the age of the kids are, which will be imputing some form of errors into our data set. Let's do this. So we do this just show representation of the title by age. So where I'm going to is, so let's fill, in addressing this, we use fill NA, group by title, using the age, taking the median, median, either is fine. It depends on what your experiment is about. So here we input the missing values with that condition. Then we have a view. So I believe we can also say that this new view is a lot better than this and this. It's a lot closer to this. So this is a larger population. So this is so this gives a better representation. Are we good?
Yes.
Okay, so this is just adding to what you knew already. Then embarked. So pretty much I'm aware of this also. Embarked as these various categories, and we have missing values in embarked. So definitely we use the most common value to replace the missing values, right or wrong?
Right.
Yeah. So there are two ways we could go about it. So it depends on how. So the first one is to use the fill NA and pick the index. This index 0 goes into this array and picks this and sets as an back value. Or we just take fill NA and specify the value there directly. So, so it depends on what works best for you. Like an example here where, so if you are, okay, I was going to mention this also. So when you're dealing with large data sets now, not necessarily in terms of, 2 million rows. Yeah, it could be 2 million rows, but your columns are like 100 and above, 100, 500, and the data set are up to like 1,000 columns. You can't be doing this one by one, really. So you need to have this being applied programmatically, meaning like the way you have this index now, you can just say, okay, after doing in your code, you could just say do, and for each categorical variable, get the value count, then get it gets sorted, then get index. Whatever the index is at 0 is your most occurring value. Take that value and set it into the missing values. So what I'm trying to say is that you will not have the luxury of time. It's impossible for you to go through 1,000 attributes by hand. So this is the point where you need to start introducing some of automation into your feature engineering process, which will bring me to some recommendation I will give at the end of the talk, for some things you need to go and check up on. You need to automate this process. You can't be doing this as an efficient data professional. Whatever you do in code by hand, try to automate it, but in some form of script, or so that you just run one of data set and saves you time. You should always work towards halving the amount of time you spend on your project as much as possible, so you can have more time to take on more projects and add more value to the organization and better yourself. So all these feature engineering cleaning steps, it would be good to for you to study and find ways to automate it for large data sets. It will really save you time. Let me get rolling there. Time is fast spent. Then for cabin also, cabin is almost missing. Is as good as removing everything. But really, for the fact that it's missing doesn't mean it's useless. Sometimes data could be missing because, the spread of data being captured from that column is not. Hello?
Hello.
Okay, I thought I got disconnected. So depending on the way the data was captured, for this feature now, 7% missing. Ideally, why should I waste my time keeping this? But you never can tell what led to this happening. So it would be good to first check if there's a strong indicator between the target variable and the missing feature. It does have an impact, no matter how small of the data that is left. Is there any direct impact? Is there any correlation with the target feature you're trying to predict? Is it relevant in any way? Then step out of your Jupyter notebook and engage the business. Why this value here? How is it generated? Do what we call a jumper walk in Lean Six Sigma. Do jumper walk. Trace your steps back how is this data being generated? Okay, what makes a data component not generated? What makes it generated? Being able to understand that will help you confidently know whether to drop the column or derive a new feature from the missing data. I mean, oh, if data here is missing, it means XYZ. Then you can have a new column at the end to better explain the data sets itself. Then, running out of time here, power transformations. So this is, I'm sure you've done this also. This is using the log attribute to better smoothen your data. Because from time to time, your data can be skewed. And when it's skewed, it will affect your model. So if you are doing a classification prediction now, and you don't have a good Gaussian representation, it can skew your model. So a good way of handling that is by smoothing, what I call it smoothing, just making the attribute more more interesting or more valuable to the model. I'm sorry, I think my connection is gone. And that was last one. Sorry. Ouch. Sorry guys, my collab got disconnected. I hope I still have something. Trying to rerun. Wow. Let me just try get just the Titanic data set and 1 sec to hold on please. Are we still here? Pardon my broken collab.
Yes.
Yeah. Try to get so I can run the last cell. I've mounted my drive. Okay. Okay. Yeah. Oops. Sorry. Come back. Yeah. Okay. So this is what I'm trying to show you. So this was the Titanic ticket fare price before, and this is after. This is better for a model to learn from. This is so skewed. It is to affect our model prediction. So what was done here was to take the log using NumPy, the log of the fare, and plot here. But do note the +1 here. This is to take care of divide by zero error. Because when you take the log on computation, the numbers tend to infinity, and this is what it looks like when to get this error. Avoid divided by 0. So that's to prevent it from happening. You have a +1 just to manage such scenarios. So largely, this is pretty much what, there's a lot to talk about, but I know you've learned a lot from Stoughton, and I'm just validating what you've learned and sharing how I use some of these things at work, and just help you know that there's a lot out there, and I'm sure you got good value from Stoughton. Do you have any questions here?
Hello.
Yes.
I have a question.
Okay, sir.
Yeah, the aspect of the before and after fair price, is it the fair price before the Titanic sank or after it? As in, why do we have to do it before and after fair price?
Oh, this before means before you applied your log transformer action to your data. The data is skewed. So it is not talking about before and after the Titanic sank. This is just addressing before you apply this log transformer, this is what your data looks like in the raw. After, so this is it here.
Yeah.
This is data as is before you added any feature engineering transformer. This is before. And after you added your feature engineering transformer, this is it. This is where you took the log, you got the log of the fair price. And this is the value of the log of the fair price. So this is a better representation of a fair price for your machine learning model than this.
Yeah.
But you can get a
I guess now.
you get, okay, it's fine. You good?
Yes.
Okay.
Yeah, and also please can we have your GitHub account as well or something?
Okay,
If you
sure.
have one.
Yeah, I do have one. I'll send it to the team. Time is fast spent. Let me move on to, let me take out this. Yeah. So let me move on to the last part of my talk. I hope not spend too much time here. Yeah, so, but so far so good. We're able to get anything, one or two here and there. Hello?
Hi, Segun.
Yeah, okay. I'm trying to just get general feedback if anybody got one or two things apart from Collins and they're okay.
All right, so it looks like nobody would want to talk, so I think we should just call names.
Oh, okay. Is there a list of?
So in attendance, we have Ayamikbo, we have Bolu, we have Collins, Kamaldeen. Yes, there's also Temitayo, and there's Ozioma, there's Ndidi, Moses, Victory.
Wow, okay. Temitayo is on my Victory. Were you able to get anything that added to what you knew already? Also confirmed what you've learned from Stoughton? Just a feedback on my.
Yeah. Okay. So, like, I was able to get more stuff, especially on the two things actually on the Titan dataset and then the original dataset that you used for the Titan dataset. I like how you were able to explain why we filled with median, with mean, and with the plots that you did. And then also with the original dataset, I like how you were able to drag it down and get features out of it without necessarily having to plot anything. So yeah, and it was pretty much well explained. The only thing I would ask if it's possible is to, okay, you already said you give us your GitHub link, so I'm guessing that if I will be there, so we could look through it again for something.
No
Yeah,
problem.
so that's it for me.
All right, cool. Temitai was gonna go.
All right. Thank you very much for your time. Like, I like the way you took your time to explain why every step you took was taken. You also made me understand that you just don't do what's called EDA or what you just did now for doing sake. There's a reason why you do each of them. There's a reason why you find out what. So thank you for that. And I noticed what's that thing called again? Power transformation. I'll read more about it. I don't know, maybe I missed the class on that, but I'm just saying that now. I'll read more about it. So thank you very much. Yeah.
All right. I think I heard Uzoma or Uzo. Did I get that right?
Yes, good evening. It's Ozioma.
Oh, Uzioma. Okay. Sorry about that. Yeah.
All right. Okay. For me, I was battling a lot with network, so I was just able to get bits and pieces. That's why I didn't want to talk at first. I was hoping to ask for the recorded session so that I can go through it because honestly, I didn't really get much from the plenty network issues I was having.
Sure. The network. It happens to the best of us. Sorry about that. Okay, no problem then. Since it's recorded, then the team will get it. So let me go into this quickly. And if you have any question around this place also, do let me know. I'll try as much as possible to talk about each one, and where I can't cover a lot, I will send in additional resources that I'm aware of that I couldn't put together right now to Okwe to share with the team also. There's a lot I can't say everything right now, so I just send a working material that the team can use to work on their portfolio and find opportunities, stuff like that. So what are employers looking for? So for
Sorry,
me,
your voice is quite low.
hello,
Your voice is quite low.
is it better now? Hello?
Okay, a bit.
Wow. Hello?
It's better, a bit better.
Okay. Okay. Yeah, so regarding what employers are looking for here, at my office, I was recruiting for my team. They were trying to expand. So technically, I'm the data science lead for the business I work in, and we needed to expand. So we've been trying to conduct interviews, and it's been hard getting a rich set of skills out there. I understand the industry is still young in Nigeria. Yeah, but there's a lot of work that data professionals in Nigeria need to do, and those who are quite good or meet what we want are either not within the country or are jet out of the country. So right now, from what I can see in the employment landscape at the moment, because of the scarcity of top talents, employers are looking out for people that are fast learners pretty much. You have a good understanding of the machine learning life cycle. You can talk about, you can do a take-home assignment comfortably. You can explain what your model is doing. You can talk about your EDA. Yeah, so if you can do all that, then you're in a comfortable position to apply for any opening within Nigeria that makes sense to you. So I would say employers look for people that are independent, really go-getters, because many of the companies I know hiring data science professionals are either fintech companies or some startup in one tech space like that. So for such organizations, there's little time to have someone teach a new hire, a new data science hire. They pretty much would like someone that can hit the ground running. though that is quite scarce, but if you're able to learn fast, and when I mean learn fast, ask a lot of questions, you get to know about the company's business in time, you learn about the processes early before even joining the company, whilst you're doing your interview, you already have ideas about what you can do within the company, then the employer will be very happy to even throw money at the staff early and let staff get learning and filling up all those gaps. But you need to be able to show that there's that passion and drive to go all the way, and not just that we are riding up the hype of data science, the best thing in town and all that. There's a lot of hype around that. There are people hyping that, but there are very few doing the nitty-gritty work that needs to be done. Out of every maybe 10 CVs we screen, maybe one just stands out. The others just pack something interesting, but they can't deliver on what the CV says. So I would say employer looking for people that can hit the ground running. Yet, yes, not professionals, not experts, but they know the end-to-end of building a data science application and can comfortably talk about it and not confuse executive, because your executive that you're reporting to, they don't know 1, 2, 3 about data science. They leave you to be the expert and expect you to explain what you've done, what you're doing to them. It depends on how small the company is. So I had a similar situation. So in my early days of working on the credit scoring application, I was on it for about a month or so. Then I had to have a review with my CEO, with my line manager. We got my line manager perfectly understands the flow and all that, the ML, the EDA, the result, the prediction, the accuracy, how this ties to the money and all that. But on explaining to the CEO, I couldn't start speaking my EDA, my linear regression, my loss function. It's gibberish to him. What he wants is how will this your model make me money or save me money? So you need to have that mindset also. So at first I was struggling on how to best represent it to him. Like, okay, the accuracy is 85%. Okay, if it's 5%, what does that mean? Oh, the false positive, the false negative. Okay. And now tied it to money. If the model predicts that, 10 people will default and they didn't actually default, it's a plus. If the model predicts that, 5 people will not default and actually defaulted, is a minus. And that minus means the company will lose money on those wrong predictions. They will lose revenue, they will lose the profit, then they will now need to incur expense of chasing down these defaulters, hire money collectors to go and chase the person down and get their money back. So do you get what I'm trying to say now? So you need to be able to tie it down to the business itself. So employers look for people that can talk the talk, as in take a data science work and translate into business that they can relate with. Yeah, so building, I can share more data, I can share more on that later on. I'll get the links and share it with him. Now building your portfolio right now, because of the way data science has grown, the standard, do your Titanic project, do your house price prediction project will not cut it anymore. Black Friday sales, it won't cut anymore. Your cargo project is not enough. Everybody's doing that. So how will you stand out? The key you want your portfolio to stand out. Why should you be different? Why should they pick out of everybody else? So still, for example, now for the Black Friday data set now, or for yes, that the Black Friday data set where you have to predict which store did well or why did this store do well. You could blend your data set with other data sets. You could pick a weather data set for transaction data. For transaction data now that had, for this one that we looked at now, you have transaction date inside. You could say, let me get a weather data set for this month, for this year that this transactions were done. what transactions here were done in the month of January. Well, let me get the data, the weather data set for the month of January from a global. There are many online. You can go to Google. There are many online weather data repositories. You can get the data set for January and say create a new feature. Just blend it for each day. Oh, on the 1st of January, that this transaction was done. What was the weather like in this country? You know, we have countries there. In this country, what's weather like on this day? And so for each day of those countries, attach the corresponding weather, high temperature, high temperature, lowest temperature, the additional attributes, feature. I still audible. Hello?
Hello?
Yes.
Am I still
Yeah,
audible?
yeah. You
Okay.
went off for a while.
Yeah, I noticed that. Okay, fine. So let me just quickly wrap this up. So you learn to blend your data set so it can stand out. Everybody's doing almost the same thing now. Add more data sets to your work. Like I said, add a weather data set to it. You could also say, oh, find out. I couldn't get to that point in this presentation. Add festivity data sets. Pretty much for those dates, were there any public holidays on those data on those days? Or it could be a signal to show that, oh, because it was a banking holiday, or people didn't do much of this, people didn't do much of that. It helps people put signals into it. The specific data said, oh, when is Christmas? Or when is New Year? Or in this country, what holidays that day is synonymous to them? So get festivity data set, or get notable event data set. Or we know that in 2020, there was the coronavirus pandemic. It's a good thing to add into your data set if you're building something off of 2020 data, either agriculture or medicine or okay, anything that has to do with dates. It could be a pointer to why certain things happen or not. It might necessarily correlate, but just to show that you are thinking beyond just one data set. Experiment, add more data sets as much as you can, and you see how it goes. Then, okay, I'll share sample portfolios also. You can look at my portfolio when I send the link. Then finding opportunities. For this one here, we don't really have a lot of data. I could be wrong, but from what I've seen so far, there ain't so much data opportunities in Nigeria like that, They are there, but you really need to stand out. Most of the ones I know are in fintech because of the fast space of the fintech industry. So you might want to probe around. If that's your area of interest, you might want to probe around lending companies. A lot of lending companies springing up now, and it'd be good to know how to do some form of credit default prediction ML, simple, straightforward, and apply to those lending companies springing up in town now. You normally don't wait for them to put out the vacancy. Just apply and say this is what you can do. This is what you've done with machine learning, and you believe you can give them such value at an early stage before the company grows big and all that. Yeah, so I know there's a lot of opportunity in fintech space here. Then it'd be good to connect to non-profit organizations also. So how many here are we aware of Data Science Nigeria?
Yes.
Yeah, so that's a good place also. I'm a member. So from time to time, there are openings that show up there that you could jump on and apply. So see, finding opportunities is my friends, it's a numbers game. Don't be disappointed if your first application was refused or your second or third or 10th. You need to just keep looking up and keep applying, read about the company, read about the company well, learn about what they do, look at their products and services, and step back and say, as a data scientist, or data analyst or data engineer, ML engineer, whatever role they put out there, how can I add value to this company? With what I know, what can I do in this company? So they have XYZ product, or they have a loan product, or they have a marketing product. How can I help improve their marketing campaign? Or marketing is pretty much, you need to do some reading up. Google what kind of marketing are doing. Are they targeting man on the street customers, or then they'll be needing some form of customer segmentation? Or how well do I know about customer segmentation? Or in marketing, there's what you call RFM, recency, frequency, and monetary value. This is what marketing campaign managers use in doing campaigns. They after
It's
getting
5 o'clock.
wow, they after getting more customers into or onto their platform. Recency means, oh, when was the last time this person bought from our platform? Yesterday, day before yesterday. Oh, F means frequency. How often does Collins shop on our site? Oh, twice, thrice, 4 times in the last 6 months. Monetary value. How much does Collins even bring to our platform in the few times they're doing it? Oh, Collins has spent over £1 million on our platform. Oh, then we need to go after Collins and make sure Collins doesn't leave. We need to make it comfortable. Oh, there's another customer that hardly comes to the site, comes there once in a while and spends really small. Or what can we do about that customer to make him like a Collins? Do some form of customer recommendation based on the products they have. So there's a lot to do in the marketing space. So you need to find that company, look at what services they're offering, see how you fit in. What can you deliver to that company? If something you need to learn it. Apply anyways. You get the interview, you push through, you don't get accepted, don't feel bad. You've learned something new, go on to the next one. You can also try international applications also. I know companies in Europe are open to remote work right now, so you could try that also. Yeah, so that's about finding opportunities. Then any other data I have, I'll send to Tim, so I don't take too much of our time. Any questions, please? Wow, time really gone fast.
Yeah, well, thank you very much for the insights. But the question I would like is, I would like to ask is, if you were to start the data science machine learning from scratch,
yeah,
considering your experience right now, how will you go about it?
Oh, awesome. First things first, I'll learn SQL. I'll not bother myself about Python or deep learning and all that. I just focus on having a good grasp of SQL, scripting, creating databases, how to use NoSQL, the likes of MongoDB, how to use stuff like Postgres. I'd rather start with that first, then move up onto, okay, now let me pick up analytics, pretty much some form of visualization. Yeah, you can use your Matplotlib or Seaborn, Vis-a-Vis, Tableau, or Power BI. It's fine, depending on what you want to do, but I'd rather start with SQL right now. If I was all over again, SQL, know it well, pretty much do whatever analysis I want to do, even in SQL scripts. Learn how to write jobs in SQL. Learn how to build data pipelines using just SQL, not even using Apache Spark or Airflow right now. You can use SQL to build raw data pipelines. Why? Because many of these companies coming on board now, they don't have the luxury of all these fancy tools and paying for support. And yeah, some of them are open source, but it's easier to blend in easily when you use tools that the company is comfortable with. Oh, MongoDB, MySQL, Postgres, MS SQL. Yeah, a lot of business logic resides inside all these SQL servers. So having a good grasp of SQL, in my opinion, now as a starter will be good. Then on top of that, you now layer up your EDA, then your machine learning and the likes of it. Because really, I'm sure students will have told you that your model is just a small component of everything. getting your data ready for use is even another kettle of fish entirely. There's a big gap in between data engineering and doing machine learning or analytics. Sourcing for data and keeping it is another tough terrain. So being able to, because before a data scientist or a data analyst, whatever title they're being given, or ML engineer, gets to have that data, somebody had spent time building data pipelines from different data sources into a central place that the data scientists can make use of. So it'd be good if you have that fair understanding of how that works also. Yeah, that's what I'll do and build up on top of that. What helped me really was that I was coming as a software engineer. So pretty much I've been doing database work, writing APIs also. So I've been doing software as well before entering data science. So it helped me jumpstart. But if not for my software engineering skills, I rather focus on my SQL first, then now build upon that. Was that okay?
Yeah, sure. Thanks.
Anybody else? Okay, so I will, for the assignments, yes, I will send in the assignments also. Nothing serious, but it's just for you to read up on something. So beyond feature engineering, there are some aspects to it that I'll need the team to read up on and um, tell me what they understand by it. Yeah. I'll send that to Okwe to share with the team also. Then in
Thank you so
closing,
much, Segun.
you're welcome. So I'll leave you with these resources also. You can get these are things that will help you stand out as well. You need to be able to think like a product manager. You need to be able to think like a business owner. You need to know how the business works. So if you can get this resource, it's a good way of closing gaps that are non-ML focused or are non-analysis focused. Because I think that I use at work today. When a business owner comes to meet me, oh, we want to do X, Y, Z, because I've gone through what it means to be a product manager, not in depthly, but understand the product management process. I am able to relate with the business owner and translate the business problem into a good machine learning question or a data science question. Then I'm able to build KPIs. So I use lean analytics to understand how to build KPIs for startups. Oh, is it number of active users per month? Oh, churn, customer churn, or retention rate, all those rate, default rate, repayment rate. You need to know all those things well so you can build good models around them. Then also the one at the bottom, business model canvas, pretty much helps you see how a business works from a startup perspective. So we are better able to appreciate what the business is doing and how you can see opportunities. Because you need to be innovative as a data scientist. If you need to be innovative, you need to understand the business end to end. So this business model canvas helps give a big picture of how a business works and what drives the business. So you know where to plug yourself and get ideas of the next data science project you can do that will add value to the organization. Yeah, so that's pretty much it from me.
Well done, Segun. Thank you so much. So, does anyone have any other questions apart from the ones that have already been asked? Any questions? All right. In the absence of none, thank you again, Segun. Thanks for making time out to be our guest. Thanks
No
for the
problem.
insights that you shared. So, we hope when we call you another time, you'll be available.
No
So,
problem.
I'll reach out to you via mail to get the slides that were used and any
Sure.
contact details that you're willing to share with the class as well.
Yeah, I'll do that.
All right. Awesome. Thank you so much again. Do enjoy the rest of your
Likewise.
evening. Yeah.
Yeah.
Bye-bye, everyone.
Bye. Bye, guys.
Bye.
Yeah, right. Thanks.